Welcome to lesson 1 of the topic Matter 2. The title for this lesson is States of Matter, and the question that we are trying to answer today is how do atoms behave in different states of matter? Our keywords for this lesson are atom, element, solid, liquid, gas, vibrate, and energy. Now the first thing that we need to do for this topic is to complete a knowledge check. So give yourself enough time to answer all 8 questions before the answers appear. So for question 1, the smallest part of an element is an atom. The name of columns in the periodic table, remembering that they go downwards, so they are vertical. These are called groups. The name of rows in the periodic table, so going across horizontally, those are called periods. The 2 main sections of the periodic table are metals and non-metals. To complete the sentence, elements in the same group have similar properties. The units of energy are joules, and you represent those with a capital J. The 3 states of matter are solid, liquid, and gas. There is a 4th state of matter called plasma. Since it is asking for the 3 main states of matter, then solid, liquid, and gas are the ones that you need to answer this question. And the units of temperature are degrees Celsius. We use the symbol shown in the table as the symbol for degrees Celsius. We start off with talking about the 4 states of matter. So all matter is made from atoms and can exist in 4 different states. These are solids, liquids, gases, and plasma. Now there are some other states of matter, but they are very complicated to understand. So we only really look at these 4 states. Now the 4 states of matter depend on how much energy the atoms have. As atoms gain more energy, usually through heating, they change between these states. So they can change between these different states depending on their energy. Now plasma is slightly different from solids, liquids, and gases, so you will learn about those separately. We will touch on plasma in this lesson, but we will learn about it separately. Now, the first thing that you should do is turn to a notes page in your booklet and draw 3 boxes. And I want you to try and remember what the atoms, the particles, in each solid, liquid, and gas as states look like. So just try your best to remember what the particle diagrams look like for solids, liquids, and gases. Pause the video to make sure that you have enough time to do all 3 before the answers appear. So for solids, the particles should be in neat rows, so regular arrangement. They should all be touching. The particles in a solid have strong forces of attraction between them, strong bonds holding them together. So therefore the particles in a solid are close together, they should all be touching, and in a regular arrangement. So they should be in neat rows. Now we need to remember that solid particles, they do not move around. They vibrate in their place, so they vibrate, so they move a little, like wiggle, but they do not actually move around. They are stuck, they are fixed in place. As for liquids, the particles still need to be touching, but they have lost this regular arrangement. Their arrangement is now random. So they do not need to be in straight rows. They should be randomly arranged, but they still need to be touching because they still have forces of attraction between the particles. Now we need to remember that liquids flow, so their particles can move around each other, but they aren't able to move as freely as the particles in a gas. Last of all then, the particles in a gas, or the atoms in a gas, they are spaced far apart. They do not need to touch at all. Again, still a random arrangement, and gases can still flow, but the forces between them, the attractive forces, are so weak that the particles, they are free to move around. Hopefully that was a good recap of what the particles or atoms in each of these three states of matter look like. So solids, liquids and gases. So make sure that you mark your work, make any corrections that you need to, because you will need these diagrams later on in the video as well. Make sure that you turn back to the lesson page in the booklet. So, changing between states. Now, we will use the element carbon as an example. So at room temperature, around 20 degrees Celsius, it is a solid. So the state that it is in at room temperature is solid. So therefore the atoms are in fixed positions. They do not move, but they vibrate slightly. Heating carbon though to 3,550 degrees Celsius will give the carbon atoms enough energy to overcome the bonds between the atoms, and they will start to flow. So the carbon then becomes a liquid. It changes state from solid to liquid. Once we heat the atoms even further, to 3,825 degrees C, this gives them so much energy that they are now free to move about completely. And this means that the gaps between the molecules, the particles, are very large gaps. So it is now a gas. The particles are free to move around completely. So it has changed state again from liquid to gas. Now the temperature at which a substance changes from solid to liquid is called the melting point and is measured in degrees Celsius. So remember that the unit for temperature is degrees Celsius. So the melting point, the temperature at which a substance changes from solid to liquid, is called the melting point. When a substance changes from a liquid to a gas, it is called the boiling point, and again it is measured in degrees Celsius. Let's have a look at this in terms of a diagram then. So we've got our solid, liquid and gas. Make sure that you turn to your diagrams of solids, liquids and gases. And make sure that you add then these extra notes. So when a substance turns from solid to liquid, we call that the melting point. So it goes from a solid into a liquid. And usually it's through heating it to a certain temperature, and that certain temperature is then the melting point. At the same time, at this point, if you have a liquid, then it will start turning into a solid. And we should know that that process is called freezing. So a liquid freezes into a solid. So depending on which state you have to begin with, at a particular point it will either melt or freeze. And it is the same point. It is the same temperature that a liquid will freeze into a solid, or a solid will melt into a liquid. Now, something that we need to be aware of is that these temperatures are different for all the different things that we know. So the main one that we know is water. Water melts at 0 degrees. But carbon, as you know, has a different melting point. And all the other elements then have their own melting points. So there's no one melting point for every element. They are all different. When we go from a liquid into a gas, that is then called the boiling point. Now again, we're very familiar with water. Water's boiling point is 100 degrees Celsius. But then it is not the same then for carbon. Carbon has a different boiling point, and so does then every other element. So it just depends what substance you are looking at. Now we should know that at the same time then, gases will turn back into liquids, and that is called condensing. So at the same point as a liquid will boil into gas, gases will condense back into liquids. It is that same point. So you just need to be aware that although we specifically look at melting points and boiling points, we need to remember that the opposite process occurs at the same point as well. Okay, so make sure that you've got those notes on your diagrams. You can pause the video to make sure you have enough time to add those in. So now we will have a look at some examples of elements and their melting points and boiling points. So make sure that you turn back to the lesson page. Now, as I've said before, so we know the temperature that water melts and boils, 0 degrees and 100 degrees. But these elements then melt and boil at different temperatures. Some are higher, some are lower. And it just depends. It depends on that particular element. Particularly the forces in between those elements, the bonds that need to be broken for them to change state. Now, if we have a look at hydrogen's melting point and boiling point, that's the first one in the table, we see that the melting point is minus 259 and the boiling point is minus 252. Now, it's strange to think that hydrogen will melt and boil at around the same temperature. They're both around minus 250 degrees Celsius, which is an extremely cold temperature. That then means that the hydrogen in the room right now has already boiled, but it doesn't feel hot. So it just depends on an element's particular properties in terms of its melting and boiling point, at what state it will be at room temperature. So hydrogen is a gas at room temperature. It has already become a gas. Now that is strange to think, and obviously all elements are different, so they all act differently. But that is just something to be aware of, that some will be really high, some will be really low. It just depends on the element. With this in mind, so what we've learnt about so far, you need to be trying to answer these 3 questions. So make sure that you pause the video and try to answer these 3 questions as best as you can from the learning of the lesson so far. So our first question is, describe what happens to atoms in a solid when they are heated. Now the particles in a solid already vibrate slightly, but heating a solid gives the atoms in the solid more kinetic energy. So they vibrate more, they move just that little bit more. They don't move around, they are still fixed in place, but they start to vibrate more. This then links into question 2, which is, explain why a solid eventually turns to a liquid when it is heated. Now continually heating a solid gives the atoms in the solid enough energy to overcome the bonds between them. This means that eventually the atoms will start to flow like the atoms in a liquid. So as you heat it more and more, the atoms in the solid move more and more, so they vibrate more and more until they can overcome the bonds keeping them together. This is then when they can move around, okay, they can flow, they can move around each other, and that is then when it becomes a liquid. We call that the melting point. So the melting point is the temperature at which a solid becomes a liquid. Now question 3 is, suggest how heating affects the bonds between atoms and molecules. Heating a substance provides energy to the atoms and molecules, which allows them to overcome the bonds between them. So if you have a liquid and you heat it even more, then it will become a gas. So that the particles in the liquid have even more energy, so they'll move around even more. They can then overcome the bonds left between the atoms, and they can then be free to move as gas atoms, as gas particles. So the the answer to question 3 is how substances change state. It's how a solid goes to a liquid, and then a liquid can become a gas. It's by overcoming the bonds between the atoms and molecules. Now we have a table showing us melting and boiling points of the elements in group 7. What you need to be doing is using the graph, so you can see it on the bottom right. You have this graph sheet. Okay, it has all of the information there, so you just need to plot the points. So follow the instructions, so 1 to 4, and then answer the questions below the graph. Make sure that you read the questions carefully as well. Make sure that you read the instructions so that you know what to do. Make sure that you pause the video before the answers appear. Okay, so your graph afterwards should look like this. So for each element, you should have a cross and a circle representing each of the points, the melting point and the boiling point. And you've then got a line, a horizontal line, across the graph. So if you need to make any corrections, then please pause the video and do that. Now, in terms of the questions then, you need to be using the graph to answer these questions. So the elements that are gases at room temperature are fluorine and chlorine. You know this because both the circles and the crosses are underneath that line of the room temperature. So they have not only melted but also boiled underneath 20 degrees C, which is the room temperature. The elements that are liquids at room temperature are bromine and iodine. We know this because they have melted, so the circles are underneath the line for the room temperature, but the crosses are not, so they have not yet boiled, which means they are not gases, they are liquids at room temperature. The only element that is a solid at room temperature is astatine. We know this because both of the circle and the cross are above the room temperature, so it hasn't melted yet at all. It is still a solid. The next question says, suggest which element has the weakest bonds in its atoms. Now, because fluorine has the lowest melting point and boiling point, that means it needs the least energy to overcome the bonds it has. That is why fluorine has the weakest bonds. For the last question, using your graph, describe the trends you see across all of the elements. So generally as you go down the group, the melting point and boiling point increase. The only exception is the melting point of iodine. Notice that the melting point of iodine is past minus 100. It's lower down than minus 100, which doesn't fit the trend. You can see that the overall trend is that they increase as you go down. But that is not the case for iodine. Make sure that you mark your work and make any corrections that you need to. Now we will talk about sublimation. Now sometimes a substance can change from solid straight into gas without becoming a liquid. This is called sublimation, and it can also happen from gas straight into solid. It skips being a liquid and goes straight from gas to solid. So it can be from solid to gas or a gas to solid. Okay, now we will talk about plasma. So plasma is the fourth state of matter and only occurs in some elements. Once an element becomes a gas, if it is heated very quickly to 5,000 degrees Celsius or above, that's a very high temperature, it can change the number of electrons in an atom. Remember that electrons are subatomic particles. That means they are part of an atom. So heating an element very quickly can change the structure of an atom to have a different number of electrons. This causes it to conduct electricity very easily. So some examples of plasma are lightning strikes, neon shop signs, and plasma TVs. Now there is a video that you can watch based on plasma. If you search Fuse School Plasma in YouTube, you will find a video to watch based on plasma. I believe that Fuse School also has videos for the other states of matter as well, so do check those out if you are interested. Now we come to this very useful table. So this table has all of your 4 states of matter, and it shows the particles, so the atoms, how they are arranged, and it then gives you an idea of what the particles are like in this state. So in a solid, the atoms are in fixed positions, they are arranged in rows or columns, so they have a regular arrangement. They vibrate, but they do not move around. They only vibrate in place. And they have a fixed shape. Because the atoms can't flow, and they are fixed in place, then solids have a fixed shape. Liquids are free to flow, so the atoms can move around each other, but they are still touching because they have still bonds between them. They are, though, a random arrangement compared to the regular arrangement of a solid. And because the atoms can flow, liquids can take the shape of a container. Similarly, atoms in a gas have a random arrangement, but they have gaps between the particles, so they are no longer touching, and they are free to move around completely. So a gas can flow, but the particles can move around completely compared to a liquid where they can only move around each other. Because they can flow, gases can then also take the shape of a container. And lastly, plasma is very hot. The atoms lose or gain electrons. Okay, so there is a change in the number of electrons, but they might gain some, they might get more, or they might lose some, they might get less. But this change in the amount of electrons means that they can conduct electricity very easily. They can let electricity flow through them. And you can see then in the diagram underneath the atoms in plasma. So they have gaps between them, much like gases, but you can then see charges due to loss or gain of electrons. Okay, the last thing that we need to do for this lesson is a knowledge check. There is also an extension activity that you can do as well. So have a go at the questions, make sure that you have time to answer all of them before the answers appear. Okay, so for question 1, all matter is made from atoms. The 4 states of matter in order of, this is in terms of energy. Okay, so solids have the least energy, then liquids, then gases, and then plasma. Remember that changes of state happen due to their substance getting more and more energy. Now, explain how atoms gain more energy. This usually occurs through heating. So giving it more thermal energy allows the atoms to have more kinetic energy, so they can move around more, which means that they can overcome the bonds between the atoms. The process of solid to liquid changing state The atoms in the solid need enough energy to overcome the bonds between them. When this happens, the atoms start to flow like the atoms in a liquid. And remember that this is the melting point. The temperature that this happens, so a substance goes from solid into liquid, is the melting point. The process from liquid to gas, the atoms in the liquid need enough energy to overcome the remaining weaker bonds between the atoms. When this happens, the atoms will be free to move around like gas atoms, and that is when liquid becomes a gas. Again, remember that the temperature that this happens in degrees Celsius is called the boiling point. And then sometimes a substance can go from a solid straight into a gas. This is called sublimation. The atoms in the solid need enough energy to overcome all of the bonds between them very quickly. When this happens, the atoms will be free to move around like gas atoms. So remember that this is called sublimation. Make sure that you add that word if you do not have it. So sublimation. It is written in your booklet, so you can copy the spelling from there if you need to. Now for 7, the state of matter with a fixed shape is solids, and the states of matter that can flow are liquids and gases. For the extension activity, explain the following statement. So helium at room temperature has already boiled even though it does not feel hot. So this is because helium's boiling point is below room temperature. So it has already changed state into a gas even though it's not very hot. This must mean that helium's bonds are not very strong. They do not need much energy to break those bonds and become a gas as a state. So the helium can quickly go from solid into a gas at a low temperature. Make sure that you mark your work, make any corrections that you need in a different coloured pen, and give yourself a mark out of either 8 or 9. That is the end of the lesson. Thank you.